All right, looks like I'm live. So welcome to Math 706, the Theory of Numbers. It's being offered spring 2015 as an online course through K-State Global Campus. So I'm Todd Cochran, and if you want to register for the course, you can come to K-State Global Campus, type in Math 706, search, and there it is. Okay, so let's go back to our website, and let's just run through the website to give you some idea what the course is about. So it's an introductory course on number theory, but it's for the graduate student level. So number theory is kind of an interesting subject because you can really teach it at any level from grade school to graduate school. And so you have to try to fit the students that you have. For this course, being a graduate class, I like to assume that every student has had some first course in proofs already, and preferably that you've had an introduction to modern algebra or abstract algebra at some point. If it's been a while, or if you haven't had introduction to abstract algebra, at the end of my notes I have an appendix that kind of summarizes all of the important concepts that you would need for this class. And it's not a whole lot. Mainly I just want you to be comfortable with the language, like what's a group, what's a ring, what's a field, because it makes it nice to state our theorems in number theory using this type of language. So you can let me know what your background is with that, if you have any questions. Okay, so there is no required textbook for the class. So if you already have any introductory number theory book, that should work out. Probably the textbook I follow most closely is the book by Niven, Zuckerman, and Montgomery. Another one I might suggest is Rosen's book, Elementary Number Theory. But there is no required text. The class notes themselves is essentially a textbook. So if you click on the class notes, you can see the contents of what we cover in the course. So generally, our one semester 706 class will cover chapters 2 through chapters 10. But in these notes, I've also included further topics that I sometimes offer as a sequel to this course. Now, if you find that you're already advanced and know a lot of the material in these first chapters quite well, you can let me know, and perhaps you can work on one of these later topics here. Although I'm not going to promise that I'll have lectures prepared for all of that right away. Okay, so let's just kind of go through what a typical course has. So we start off with going through the fundamental theorem of arithmetic, all the divisibility properties, unique factorization, and talk about unique factorization in other domains such as the Gaussian integers. Then we do modular arithmetic, Fermat's little theorem, Euler's theorem, study the group of units, mod p, and show that it's a cyclic group. Look at Chinese remainder theorem, more on congruences, polynomial congruences, chapter 4. Chapter 5, we will look at quadratic reciprocity, quadratic residues, and characterize integers that are sums of two squares. Chapter 6, primality testing, Mersenne primes, Fermat primes. Chapter 7, studying arithmetic functions, the Möbius function, Möbius inversion formula, estimating the tau sigma and Euler phi functions. Chapter 8, we look at recurrence sequences, especially the Fibonacci sequence. It has lots of interesting properties that we'll look at. Chapter 9, getting into Diophantine equations, Pythagorean triples, points on conic sections, studying cubic curves, and then an introduction to elliptic curves in Chapter 10, including the elliptic curve method of factorization. So that's a typical one-semester course. And then some of these later topics, if you want to glance through them, some introduction to prime number theory, binary quadratic forms, the geometry of numbers, continued fractions, Dirichlet series. You can let me know if you are ready for some of those topics. Okay, so those are the class notes, and what you click on here, it's a work in progress. Lectures. So my intention is to prepare lectures and post them on YouTube. So I've got some of them prepared already. Here's section 2.1, the beginning. So here we're studying divisibility properties, greatest common divisors, and proving the fundamental theorem of arithmetic. And you can kind of pace yourself. If it's going slow, you can come over to the settings and speed me up. 36 times 10. Blah, blah, blah. Or if you need to slow me down, you can 90 times 4, like that. Okay, that's too funny. Go back to normal speed. And if you like, you can open a second page. Oops, and
3 squared times 5. I'm getting exactly the same factorization. So that's what the fundamental theorem of arithmetic is. It's simply the statement.
Put the notes up here, class notes. There we go.
Any positive integer can be uniquely factored
so you can
into a product of products.
You can see how I'm following the class notes.
Why this is true.
Are you recording?
Yes. It's recording. Yeah, so I'm following the class notes right here.
Let's pretend for the time being that we only have even numbers.
So if you just prefer reading the material, you can just read along like that.
So 360 I could see is 30.
Okay, so let's go back here. Lectures, homework. Okay, so as I said, every 2 weeks you should turn in a homework assignment. And you can either mail it into me or scan it and send it directly to K-State Online by the due dates here. And I'll try to post some hints to the homeworks. Let's see if I don't have this one up, but if you want to see fall 2014, I put a link here. So there's the first homework. Just do any 8 problems on this one. Studying basic divisibility properties. Here's Gaussian integers and so on. And we'll try to set up some time when we can all meet and chat, maybe some Zoom sessions. It's kind of like Skype, but at K-State they use a system called Zoom, where you can talk live with me and ask questions. Course summary, grading. So 60% of the grade is the biweekly homework assignments. We'll have a midterm and final, and those will be proctored tests. Part of the midterm, I'll give you some take-home problems, like another homework assignment. And I think that's it. You can send me email. Feel free to email me. My email is listed up here if you have any questions. So let's sign off for now.